So, today I was driving 6 o'clock to the job to write this presentation, and radio was transmitted one very, very exciting song which had words just like about my machine. It all starts with one. Everything comes from something. Nothing comes from nothing. It all starts with one. Anne Brun, that's Scandinavian she song there. Practically, if we meditate about that, these words are just telling about very fundamental nature's laws, that there where is a crowd, happenings more crowding, and where is the emptiness, it becomes more emptiness inside. You see that in the trees or about many things in the nature. However, I'm not capable to dare to say which is those one. Is it our project's angel Arnold Zubelis, or it's just project Fotonika-LV, or probably it's money of Europe which is supporting us. But anyway, everything starts with something. And in my case, it was just we get ideas that Gothenburg University is willing to help us to lift up some new machinery, and we gathered quite much of people which understand something about the techniques, so everything started. They had a full cellar of decommissioned machinery, and we had get a permission to just screw off everything what we count it would be beneficial to our machine. Of course, we had some plans in head what we want to get, but just this was one of the first minutes of being our GRIBA. GRIBA, that's the Göteborg Riga Ion Beam Apparatus. Or, if to translate in poor Latvian, it means the willingness. So, we started with the frame, ion source, power supplies. The ion sources itself, we have 1.5 maybe sources. One is that which is installed at this moment, the filament method, just some carrier gases superheated and then ionized, and it brings out of the small hollow cylinders that sample substance molecules and forming an ion beam. Another method is just half done. It's a radio frequency ICP plasma cell that is a little bit more savior to molecular form samples. So we are just trying to sooner or later organize this spare cell let to be just easily shiftable one or another. Here is about the principle how it's built in. Just where it is. This. Here you put the carrier gas in. Here it's that sample substance. Then it's the spiral, the heating wolframium. Then some heat-resistant boron cylinder, in which this plasma bubble is happening. Then a small hole or aperture and extraction electrodes. So everything is quite simple. If we see in the circuits, when we see in the nature, it's much more complicated, of course. As soon as the ion beam is formed, all the ions are coming to the V in mass selector or velocity filter, you can name it that way too. Just it's quite much of the regulation knobs, but after short learning, you know what must be, how turn it to adjust machine for only one type of your ions, and all other ions will be cleaned off. This is how it looks composed together. Everything what I told until this moment, except that here is that magneto-electrostatical this Wien filter what you see in the hole. Here is a circuit how it works. Quite simple. It's of course cooled with the distilled water and so on. It's much of the techniques inside. Here is the next unit which is on the carriage, on that frame. That is a cesium charge exchange column. Just if you extract the negative ions, that's very easy. Negative will come out. But if you compare with the positive ions, what you can extract with the same conditions, the negative flux will be about factor of 100 less. So it's more better if you extract the positive ions and just change the charge to opposite. You have larger beam currents then. Then the third unit is what is again on the rails. It's a quadrupole deflector which sorts the ions, positive charge at the left, negative charge at the right, and non-charged, not the ions but particles, straight. So here is a very intriguing moment. Do we calculate it right? Probably 1 millimeter will be missed and we shall fail. But of course everything was solved. Then it's in the machine is built at plenty of smaller details, such like a deflection plate. You know that it's very high accuracy details with a micrometer accuracy. But after a little bit training, the hands are capable to compose it together, everything that is composed by us. For control of beam, we use a Faraday cup current detector. It's very simple structure too, only one thing is important, the accuracy, accuracy, accuracy. Here is a quadrupole, that which are sorting the charges. Let's, at the right would go only those negative which we are interested in. And the last detail is time-of-flight electron spectrometer, which generally has the same principle as a particle TOF, but with a small difference. Particles you need to accelerate before measuring. Electrons you need a little bit breakdown before the measurement. So generally they are the same. In the end, in the left side, you see the bundle for MCP detector. This particle beam is going in the very bottom, somewhere here. In this hole, or alternatively this hole, or alternatively that hole, you can push the laser beam. And then this charged particle is depleted, and you can measure the electron affinity of that electron which is stuck in the MCP plate. One more detail. Everything must happen in an absolutely best vacuum what you can imagine. So we composed in that last chamber the super turbo pump plus magnetic type of ion pump. It's just such box, looks very seriously and weighs a little bit less as a half ton, but needed 2 men to lift it up. So 1,000 details and maybe half of year of job, I never calculated, but much. And here you see the first slides where Aigars is composing something. My hand is 2. And of course, everything must be drawn before the some thoughts are coming in the hair. So, in the most right, you see that source. Here is this wind filter, charge exchange column, sorting by the charges by quadrupole. Here is the high vacuum section, and TOF. And, of course, laser. Laser, we are very thankful about collaboration with our astronomers. Just they had one laser which was decommissioned from a satellite ranging station. We succeeded to repair it, and now it's in a workable condition and looks quite good for our needs. Okay, this is the last view before transportation from Göteborg to Riga. That was just unimaginably story about how it happened and everything. Just we calculated the costs and risks and make a decision to transport ourselves, because only we understand how endurable this machine is and how expensive it is. So we rented the bus, driving those 1,000 kilometers to Göteborg, and then we see that our apparatus is only 1 centimeter too high to put in the bus. But of course, some innovative thoughts, and we just saw the feet a little bit lower and succeeded. And then we had the next problem that everything is too heavy, bus springs are going to down, and on the Swedish hills, bus can come only in the first gear. But anyway, we win, and when we tested here in the first days, that machinery, that nothing was damaged, everything was well justified, so transportation activity was successful. So, for the future, student training, that's one thing what hopefully will happen, but it depends from the faculty, of course. Doctorate training and working, of course, that's hopefully a most important factor which will exploit this machine with the main thing, research on spaceborne life origin candidate molecules. You know that it is plenty of such molecules, over the 800. Astronomers may say that they are published and well known. The last one, very interesting candidate, was published only 1 year ago, so we shall, as soon as the time and money will allow, we shall meter their electron affinity, so the chemists may calculate the possible reaction cross sections, and then maybe one day we shall know which is our monkey which was born just because some supernova was exploding somewhere. Other thing is, thanking to India colleagues, we are trying to little bit make this machine more advanced and install it in that GRIBA cluster source. So then we shall be capable to investigate some physical chemical reactions, photochemical reactions in different substances, and of course the main accent will be on the space, or say astronomers interesting substances. And then of course we can use, at least I can imagine that we can use this machinery for just some collaboration about check something or adjust something, because machine is consisting by the fact from mass spectrometer, mass selector, mass analyzer, ion beam, TOF, green powerful laser, and so on. So we can use just these capabilities if somehow we shall find the right consumer. And of course, sooner or later we shall need to make upgrades, because at least those which are Latvian speaking knows that folk sentence that Riga is never ready built. Just Riga is we are building now about 850 years, but it's never ready because always you have new and new ideas. But okay, last slide. What I wanted to say is that it all starts with one. Everything starts from something. Nothing comes from nothing. It all starts with one. And this one, it's a fruitful tree. We year by year hopefully will eat those fruits. But biggest thanks it's to European Union and with the RECPOT projects and Fotonika-LV. Thank you.